Ohm's law seems confusing to many students as they study for their technician class amateur radio license. Well, it really isn't difficult at all. I'll try to simplify it here. Ohm's law states that the current through a conductor between 2 points is directly proportional to the voltage across the 2 points. Simply stated, there is a direct relationship between voltage, current, and resistance. We're going to limit our discussion to DC circuits here. A quick matter of definition. Voltage is traditionally given the variable E, and the current the variable I. Why E and I for voltage and current? Voltage, represented by E, stands for electromotive force. The variable I for current originated from the French phrase for current intensity. The I symbol was used by André Ampère, after whom the unit of electric current is named. Okay, let's get to it. From our high school algebra, we know that in a 3-variable formula, all we need to know to solve the equation are 2 of the variables. We also remember that any algebraic polynomial can be rearranged to solve for a different missing variable. A equals B divided by C becomes C equals B divided by A, which becomes B equals A times C. Now let's take the classic Ohm's law formula. We use this simple graphical layout to represent the relationship between the 3 variables, voltage, or E, current, or I, and resistance, or R. This will make it easy to remember the algebra rules for rearranging a formula as needed. If we know the resistance and the voltage, we can solve for current, or I. Or we can turn it around if we know the current and voltage, but need to solve for resistance, or R. Or the third possibility, if we know the current and resistance, we can solve for voltage. It's just simple multiplication and division. Let's see how that works in a practical demonstration. Here we have a 12-volt power source, a current meter, and 3 resistors in series. Each resistor has its own voltmeter. Let's assume that R1 and R2 are both 200 ohms, and R3 is 400 ohms. First, from our knowledge of series resistors, we know the total resistance is the addition of all 3, or 800 ohms. Well, we now know the resistance and voltage, but don't know the current. I equals E divided by R, or 12 divided by 800, or 0.015 amps. Now, what is the voltage across R1? Well, E equals I times R, or 0.015 times 200, or 3 volts. Since R2 is the same resistance, we know its voltage drop is 3 volts as well. The voltage drop across R3 is E equals I times R, or 0.015 times 400, or 6 volts. Let's try something. Let's assume we don't know the value of R2, but we have a current meter that reads 0.015 amps and a voltmeter across R2 that reads 3 volts. We use the third rearrangement of Ohm's law, R equals E over I, or 3 divided by 0.015, or 200 ohms. Just what it's supposed to be. This might be a good time to talk about my other hero, Gustav Kirchoff. Kirchoff's law covers a lot of complex component network analysis, but simply put, he says everything that goes into a circuit must be accounted for. Let's look at the results that Ohm's law gave us. If Kirchoff is right, and our calculations are right, then the total of all the voltage drops across the resistors must equal the power supply voltage. Well, he's been right for nearly 150 years, and 3 plus 3 plus 6 volts equals 12. The power supply is 12 volts. So we know for sure the calculations are correct. Now see, that wasn't so hard.